A given 16 horsepower centrifugal pump has an efficiency of 83% and produces 65 psi of pressure head. What is the flow rate of water that it is able to pump? So let's start by looking in the manual for something with the word pump in it. You could also search by terms like centrifugal or pump efficiency, which might get you there faster. No matter what, you should end up in the pumps section on page 335 of the manual. So we can see here under fluid power equations that there are two equations given which we could use to solve this problem. They might look different at first, but are pretty much the same equation with some of the terms in different units depending on which equation you're looking at. For example, rho times g is actually gamma. This might not be in the manual, but it's something to remember from fluid mechanics. Additionally, the power of the pump is either given in horsepower or in pound-foot per second. The second equation even provides the conversion from one to the other. So let's lay out our units and see if we have enough here to solve for flow rate, like the question asks. First, we have our horsepower given as 16. This is the pump brake power in either bhp, or you can convert it to foot-pounds per second. Next, we have our pressure head given as 65 psi. This is our H term, or we could convert it to feet. Finally, we have our efficiency, which was given at 83%. And this is the value nu. So let's take one of these two equations and start plugging in our terms. Given that 16 horsepower is already given as the proper units here, I'm going to use the second one. So 16 HP equals Q, which is what we're solving for, gamma, which is 62.4 pounds per cubic foot of water, and you can find this in the reference manual on page 2 if you need it, but it's good to have memorized. And then finally our pressure head, which is in PSI, but we should convert it to feet to be consistent with our other terms here. So the unit conversion page of the reference manual shows that 1 foot is equal to 0.4332 psi of H2O. And on the bottom, we've got 550 foot-pound per second times nu, which is 83%, given as 0.83. So if we multiply these two things over here and isolate Q by dividing this whole quantity, we will be able to get Q equaling 0.78 feet cubed per second. And that's all it takes to solve this problem. In summary, this problem mostly requires you to do some unit conversions and know where some terms are so that everything in the fluid power equation cancels out. It'll also save you some time if you can recall the density of water, or at least know where to find it on page 2, because otherwise you won't be able to solve the problem. And that's it.